Alright guys, this is lesson 58, topic 58, Riemann Sums again. Now we're going to try to use our calculator. Now don't get too excited, we're only using it for like adding and subtracting and multiplying. So what we're going to do here is that they're asking us to sketch this graph. Notice I already sketched it. If you remember back from Algebra 2, that's a upside down parabola or a negative parabola that starts at 9. Alright, so notice that my vertex is here. And I do this. Now, I'm integrating between 0 and 3, or between 0 and 3. So, I'm integrating between here and here, so hence the shaded area. Okay, now we're going to use the Riemann sums. Now, we're going to use the left and the right hand sums, and we're going to use 4 equal subintervals. So, to figure out what delta x is, which would be the width of the rectangle, remember we have to use this formula, b minus a over n. Now b in this case is 3, a is 0, and n is 4. Right, so delta x is going to be equal to 3 over 4. Which means that this would be 3/4. This would be 3/2, because, you know, if you add 3/4 and 3/4, that gives you 3/2. And then if you add that, you have 9 over 4. Okay, so that is what you have there. So now we're trying to find, right, I'm only going to draw one of these because it kind of takes a little bit of time for me to draw these. So I'm only going to draw the right hand sum. Okay, so the right hand sum, again, I recommend that you start, you're going to start here or here, it doesn't matter. Just don't start here because there's not going to be one there. So we're going to start here. I'm going to put a point there. There's going to be another point here. And another point right there. Okay. Now this is a right hand sum, so make sure that the right of your rectangle, the right corner of your rectangle is touching that curve. Okay. Again, notice how I'm doing that. Alright, so again, that would be the right hand. And notice that the last one, the last rectangle, the right point would be right at 0. So there's not going to be another rectangle. I mean, the other rectangle is going to be 0. So where we're going to start, so again, this is for the right one. Since I already did the right one, I'm going to do the right hand sum first. So we have the right hand sum. It's going to be equal to, remember, that's going to be the width of every rectangle, which we know is 3/4 for each one of them. So we're going to simplify like this. We got 3/4 times all the heights. Right, now we're going to start here. Right, so I'm gonna write it in steps. So this would be f of 3 plus, let's see, that would be f of 9/4 plus f of 3/2, again, because that's the y coordinate. Remember, the heights are determined by plugging in the x value into this function, 9 minus x squared. So you have f of 3/4. Now notice that I did something kind of weird here. Is that I went from here and I went backwards. It doesn't matter how you do it. You could have started here from 3/4 and 1 all the way to 3. So again, it doesn't matter how you do it. Now, like I've said earlier, you can tell at least this one, f of 3, well, that's 0 because it's right there at that point. So the y coordinate would be 0. So this is 0. Now to figure out the rest, probably the fastest thing you can do is just to go to your calculator. Go to your calculator. Well, let's first clear it. And just put 9 minus x squared. And then when you go to second value, which is the first one right there, then you can just put those values in there. So if I want to try to figure out 9 over 4, this would be a lot faster than doing one at a time. Then notice that you got this, the y value is going to be your answer. All right, for the next one, 3/2, I just type in 3 over 2. And there's my second value, and so on and so on. Alright, so that's how you do it fast. Okay, so we have that this is 3.9375. This is 6.75. And then f of 3/4 is 8.4375. Alright, and that's going to give you 14.344. Okay, now to do the left-hand sum, you're going to do exactly the same thing that I did here, and as a matter of fact, some of the values are exactly the same, but now instead of, I'm not going to draw it, but basically this is going to be your first number. Okay, so that's going to be f of 0. Instead of, you're going to start at f of 0, f of 3/4, f of 3/2, f of 9/4, and so on. So notice that, I hope you can see a pattern by now. Hopefully you did your homework before you watch this for the previous lessons, but you're going to get 3/4, and this is going to be f of 0 plus f of 3/4 plus f of 3/2 plus f of 9/4. Okay, so notice that they're almost exactly the same values. I just kind of moved over to the right, to the left one, I'm sorry. Okay, so now we're going to do the same thing. We're going to use our calculator to figure out all these values. Now f of 0, well, that's going to be 9 because that's the y value there. But other than that, you probably should use your calculator to find the rest of these. And some of these you should already have from doing the right-hand sum. So we got 7.5 plus 6.75 plus 3.9375. It turns out that you get 21.094. Okay. So again, the Riemann sums, they're not hard. They're just kind of tedious. All right. So let's talk about. Actually, when I have a table, no need to actually graph this. First of all, you don't know exactly what it looks like other than you have these points. But when you have a table, it's actually faster. Notice that they want us to use 6 equal subintervals. All right. So first of all, delta x is going to be equal to 6 minus 0 over 3, which in this case is still gonna give us 2. All right. So the width is going to be 2. The width of each rectangle is going to be 2. Now, to divide this into 3 subintervals, just look at this and divide all these into 3 even parts. Now, if you notice that, if you do that, basically that's going to be 1, this is going to be 2, and this is going to be 3. All right, so those are the subintervals. Notice that, for example, to the left of the subinterval, you have your left endpoints, right? If I were to ask you, if you have a subinterval, if you have a rectangle and you're looking for the left sum, then you're going to use this number. If you're looking for the right sum, you're going to use that number. Okay, but let me just show you. So we're going to find the right sum. So we have r of 3, again, 3 subintervals. So that would imply, like we said, the delta x was 2, the width of the rectangle was 2, not the heights are going to be, and I'll show you here in a minute, are these. Now, just to make sure that, and I went backwards, but let me just go the normal way here. Alright, so I'm going to put a 2 here and a 6 here. Alright, so if I'm looking at this, just let's look at those 3 first numbers here. If there's some kind of rectangle right there, the right endpoint is going to be this one, which means the f of 2 is going to be 8.3. On between this number and this number, the right endpoint is going to be this one, which means the y coordinate is that, and then finally between 4 and 6, the right endpoint is 6, and that's going to be my y value. Okay, so that's going to give me 2. Now f of 2 here, we're going to have 8.3, positive 8.3 plus 2.3 plus a negative 10.5. Okay, and when you do that, you get that the answer is 0.2. We're at the left endpoint, so I'm going to put B here, left endpoint, Same thing, the delta x is not going to change. Now, this numbers are going to be pretty similar, but not quite. Now, between 0 and 2, the left endpoint is going to be 0. So we're going to start at f of 0 plus f of 2 plus f of 4. So again, it's almost the same numbers except I shift over to the left. Okay, so that's going to give me 9.3 plus 8.3 plus 2.3, and that's going to be equal to 39.8. Again, nothing hard about this. It's just kind of tedious. Now, finally, the midpoint. Now, this one, the midpoint is not going to be as bad as it would have been if you were doing this graphically, perhaps, because the midpoint, well, between 0 and 2, the midpoint is going to be right here, which means the y value is 9. Okay, so again, we would have 2 f of 1 plus f of 3 plus f of 5. And if we just look at the y values of 1, 3, and 5, then we get 9 plus 6.5 plus negative 7.6, which is equal to 15.8. Okay, so again, I haven't really covered anything much different, except for your homework's longer than yesterday. All right, so let's take a look at the back. Now, the back is going to take us a little bit. You're probably going to need an extra piece of paper because I did. All right, so let's take a look at the back. This is a word problem, so prepare yourself mentally. Now, on this one, they tell us that R of t is the rate of fuel consumption. Okay, now they give us this table. So notice that the first thing I look at is that the delta x, or in this case delta t, they're not evenly spaced. All right, and that's going to come into play later. So, and it's twice differentiable, which is an important fact because now we know we can do a few things with this. So on A, example 3a. The first thing it's going to ask us is to use the data from the table to find the approximation for r prime of 45. All right, so here's, if this is r, 45 is somewhere, you know, it's somewhere like in here. We don't know. Okay, now it's somewhere in there. However, we don't know, like it doesn't tell us right here where r of 45 is. Not that it would matter anyway, but we know that r prime of 45, all right, r prime 45, that's the derivative at 0.45 of this one, okay? So basically what I'm looking for is the slope. This means this is the slope at r of 45. Okay, so again, that's really what I'm looking for. Now, unfortunately, I don't know what the point is, but we can approximate because we know that the slope at that point, right, if we can take the derivative at that point, it would be great, but we can find the slope between the 2 points that are around that R45. Okay, so the 2 points around 45 that we know of for sure, notice that you have 40 and 50. 45 is between those two, so the slope formula, all this is the slope formula. So we have r of 50 minus r of 40, which basically means the y value at 50 and the y value at 40 over 50 minus 40, which is going to give us 55 minus 40 over 50 minus 40, which is approximately, alright, so this is going to give us a good estimation of what this is. Gallons per minute square. Okay, so again, that is going to be the slope. Again, we're approximating. We have a slope right here. If you look at it, okay, we have a slope right here, and that's what we just found. We approximated that by using the slope formula. Right, kind of similar to the derivative formula. Okay, so now let's take a look at 3b. Now on 3b, I actually wrote this ahead of time because that's going to take a little bit of time. Now B is asking us the rate of fuel consumption is increasing fastest, and that's actually a very key word on here, at t is equal to 45. What is the value of the second derivative at 45? Okay, so basically what that means is you have the steepest slope at that point, okay? So here's what that means. Now I would probably read this before I copy that down, but r prime of t is a rate of fuel consumption. Since r prime of t is the greatest at t is equal to 45, and there's a local max, not on the graph that you're looking at on the notes, but on the graph of the derivative of that graph. Because r of t and r prime of t are differentiable. Okay, so let's just cut through the haze here. If you have the steepest slope at 45, that means you have a max on the derivative, and then if you remember, the second derivative at that point is going to be 0. Right? So if you have a max on the derivative function, the second derivative of that function is going to be equal to 0. Okay, so I know that was kind of confusing. If you don't understand that, that's okay. We can talk about it when I come back. Now on the next one, on 3c, let me bring 3c back here. Alright, we're trying to approximate the value of the integral between 0 and 90 of rt dt using the left. Alright, so we're using the left Riemann sum with 5 intervals indicated by the data in the table. Alright, is this numerical approximation less than the value of the integral? So if you're actually doing this with with math, with calculus, is a Riemann sum that we're about to do less or more? Okay, now first let's go ahead and draw this picture. Now remember that we're using the left sum, right? Now they actually even put the points on here, which is kind of nice. Alright, now what I'm going to do here is I'm actually going to draw lines that connect to that point. Okay, and then what I'm going to do from here is that this is going to be the left sum. So it kind of makes sense to do it when you're doing a left sum for an increasing function. It kind of makes sense to kind of start on the right for me, but anyway, up to you. So that's what that's going to look like. Now notice that, like I said at the beginning, the differences between these numbers it's the delta x in this case is going to be different. They're not evenly spaced, alright? So they're uneven intervals, or delta x is not constant. So I cannot reorganize this to look like this. I just wrote it horizontally. So if I write it horizontally, right, notice that 3c, right, delta x, in this case, let's see, the difference between those two numbers is 30. Difference between those two numbers is 10. Difference between those two numbers is also 10. Difference between those two numbers is 20, and same here. Okay, now what we're going to do here is we're going to find L of 5. Alright, notice that again, delta x is different every single time, right? And we're looking for the left sum. So between those two, the left point would be this one. So we're going to have 20. And on this one, I can't really do this any faster than this. Times 30. Now 30x in this case is the delta x. Right, so this is basically the width of the rectangle, and this 20 is the height. I'm sorry, I got that back. Yeah, 20 is the height, 30 is the width. Plus, let's see, between those 2 points, the left one is that one, which means 30 is my height, and my width, excuse me, my width is going to be 10. So again, this is the delta x. And between those 2 points, the left endpoint is that one, which means my height is also going to be 40 on this one. My delta x, well, my delta x is going to be 10. And I'm going to do the same thing. Okay, so between 50 and 70, 50 is the one I'm looking for, which means the height is 55. Delta x is 20. And then we got plus, between those two, the left endpoint is that one, which means the height is 65. And this is also the delta x. And when you do all of that, you get that the answer is 3,700. Now hopefully you can tell by the picture, but on the approximation is going to be less than the actual value because you have an increasing function. So again, it's asking you if you're going to, approximation is going to be less and more. So the Riemann approximation is less than the actual value because R of t is increasing. That's an increasing function. Okay, so last on this notes is on 3D. Let me look at it here. All right, on 3D is telling you right here that between 0 and 90 minutes, explain the meaning of this in terms of fuel consumption for the plane. Explain the meaning of 1 over b in terms of fuel consumption for the plane. So notice that these two are basically the same, and they want you to indicate the units of measure in both answers. So the first one's actually not too bad. If you have the rate of consumption, okay, if you have the rate of consumption was R of t, so the integral of that is going to be the total gallons of fuel used. Okay, so that's going to give you the total gallons of fuel used from t is equal to 0 to t is equal to b. Now remember that b is minutes. All right, so both of these are in minutes. So the next one though, the next one's going to be a little bit different because if notice that this is the same thing, by the way, as writing this over b. Okay, now since we kind of talked about that the integral of RT is the total gallons used, well, this is going to be the total gallons of fuel used. And B, well, if you remember, B is a type of time. All right, so B is time. So what this really means is that this is the average gallons used per minute. Now, if you don't understand all this, if I went too fast, make sure you go through all of this again. Hopefully you watch this ahead of time. This takes a long time to watch. So take a look at, rewatch this if you have any questions, but the homework I think is a lot easier. All right, so much so that I'm going to do one problem on this. So let's look at our homework for 58. And let's look at this. I'm only going to do one of these, all right? So again, nothing too incredibly hard. It's just a little bit different. All right, and I'm going to find the right-hand sum, the right sum. All right, we're going to find delta x first. Now delta x, remember, was 3 minus a negative 3. And how many intervals do they want? 6. All right, so that's going to be 6 over 6, which is 1. Okay, so the intervals are going to be 1. So, and they want to go from negative 3 to 3. All right, so we have a right-hand sum. So what I recommend you do is go from the x-axis and touch the right-hand side. Notice that I'm starting from the right-hand side. Okay, so from the x-axis to touch the right-hand side of everything I can here. So notice that I'm just going to touch I'm just going over 1 and I'm drawing a line, and I'm touching that graph. Okay. Finally, let's see. Now, I'm not going to go any further in this because then if I'm doing the right-hand sum, I need to stop there. All right, because that'll make this the right side of my rectangle. So my right side right here would be this one. See, on this one, I'm going to go down here, draw that one. I want this to be the right-hand side, so I'm going to draw this. Oh, right-hand side is that one. Right-hand side is that one. And then finally, the right-hand side on this one will be all the way over here. Okay. So there's going to be some approximation being done. Some of those numbers are precise, but let's see. So in A, I have that the right-hand sum is going to be R of 6. Now remember, the width of the rectangle is going to be 1, and we can see it here. Okay, so the width is 1. Now the heights, well, just look at it. Okay, this one's going to be the height of 1. Plus, let's see, the height of this one, we're going to say that this is a negative 1/2. Let's see what else we have here. We're going to say that this is negative 1.5. And notice that I have decimals and fractions. If you want to change them all to decimals or fractions, that's fine. Plus negative 1.5 again. Let's see. This is a negative 1/2, so negative 0.5 plus, now the height of this one's about 2.5 or 2.5. Now you get that the answer for this one is negative 1/2 or negative 0.5. Now obviously your answer might vary a little bit. If we could disagree here, we can say, well, that's really 2/3 or whatever. But try to keep this example in particular in halves. Alright, so hopefully you can do this, and good luck out there.